In this 10th grade class, students are learning a new mathematical concept. As you watch, notice how the teacher challenges students with rigorous content and encourages them to take ownership of their learning.
We have to divide x by both sides. We can't leave it like that. We have to divide the plan into one of both sides, and then we get 138.6 feet.
What do we think?
Excellent.
Any questions? No questions. We all feel great. All right, blast from the past, we're right there. Now, what was the challenge about? What happened? Why was number 3 so challenging?
Because it had so many degrees.
So many degrees. Okay, so Emosafe says there's too many angles. That was confusing to her. Matthew?
I said it was too hard to figure out what we needed to solve.
Okay, hard to figure out what we needed.
I also didn't know the first one.
Too much information? Okay, too much information. All right, Roderick, you got to choose. We have 2 different solutions written on the board, and we have 2 different answers. So I don't want anybody copying down either of those solutions. Those are going to be up for a few minutes. Nope. Okay, what's your question?
How would you know how often in order to know that?
Okay, so hop up there and ask your teammate how he knew that. Okay, so can I have a volunteer, someone different than Roderick, someone I haven't heard from, can I have a volunteer to read number 3? Someone I haven't heard from, I need a volunteer to read number 3. Khadijah, let's hear it.
Juan and Ramela are standing at the seashore 10 miles apart. The coastline is a straight line between them. Both can see the same ship in the water. The angle between the coastline and the line between the ship and Juan is 35 degrees. The angle between the coastline and the line between the ship and Ramela is 45 degrees. How far is the ship from Juan?
Okay, so yes, there is a lot of information. What do you think the first thing that I would have wanted you to do was?
Draw a diagram.
Draw a diagram. This is hard. This is hard to figure out without seeing it in front of you. So, Roderick, take us through Jeremy's diagram, and let's talk about if we have any feedback on it.
What Jeremy basically did was he drew the coastline, and he knew that it was 10 miles. So he put 10 miles up here, separating Juan and Romela.
Why can't we use this 5? Right, there you go. Beautiful. All right. So we've realized I gave you a trick problem.
Yeah.
Okay, fair enough. We got to it. But I promise you.
By the end of this, we going line.
Oh, I promise you will be able to know how far that ship is from Juan really soon. Okay, so here it is. The title of today's notes is something called, keep your calculators handy, you're going to love it. It's almost as great as SOHCAHTOA. Law of Signs. So get down the title, Law of Signs. And Tony, could you read the objective, please? For a full homework pass, at your big boards. You guys, I've stepped up your big board. You get to use chart paper. What? Okay, at your big board, you have to prove the law of signs, but I'm giving it to you.
Oh, okay.
You're welcome.
So we can write that?
Nope, you're still not writing it down. You're proving it using this diagram, and I'm going to give you 2 hints. But since there's so much at stake, there's a time limit on it. You have 5 minutes.
10 minutes.
Oh, 10.
What is 7?
5.5. You're welcome. 5.5. Here it is. 5.5 minutes to prove the law of signs. You don't need any numbers. You can do it with all variables.
Oh, which triangle are we looking at?
You tell me. So you guys have done both of my hints, correct? Okay. I'm going to ask you one question and then I'm walking away. You have 2 different equations for H. Is that H the same thing? Woo, bye. All right, we ready to use this law of signs instead of proving it? Because then you'll be able to get Juan and Ramela.
Technically, I thought
No, we gotta know how far Juan is from the ship. How will you be able to sleep at night? Ah, you need to be in degrees. You're fine. You tell me. You guys go to each other's boards. Find a mistake. You find a mistake on someone else's board, you get a point. Go.
Hold up. I didn't even try that.
It's called point eight, y'all.
It don't matter which one you do.
We got a point, Miss Fish. We got.
In this clip, students have multiple opportunities to meaningfully interact with rigorous content. Let's look at how the teacher gives students time to grapple with a new concept and push their learning forward. First, to ensure that learning experience is challenging, the teacher chooses content that is aligned to the Common Core state standards for this course. The ultimate goal of the lesson is that students can both prove the law of signs mathematically and apply their understanding of the formula to real-world scenarios. The teacher begins by having students work on 3 warm-up problems, the last of which, about proximity to the shore, is a challenge problem. After the class shares their solutions for the first 2 problems, the teacher asks students to list the components of the challenge problem they are struggling with before having them read it aloud and discuss possible strategies for solving. The teacher chooses not to reveal to students that they actually need a new formula in order to solve the challenge problem. Her approach ensures that students figure out that they need additional information on their own. We see students draw diagrams that represent the challenge problem and use what they know to come up with 2 possible solutions, but after critiquing their work as a class, they determine neither possible solution is correct. Now that students recognize the need for additional information in order to solve the challenge problem, we see the teacher introduce the law of signs. Her instruction is brief, which maximizes time for students to practice with the new material. The teacher offers students 2 hints, and then releases each group to prove the law of signs using variables instead of actual numbers from the challenge problem. This ensures that students develop a conceptual understanding before they apply the formula to the real-world scenario in the challenge problem. As groups work through the mathematical proof, we see the teacher circulate to make sure students are using the 2 hints that she provided. She asks targeted questions that provide each group with just enough information to move forward without doing the thinking for them. This results in all groups successfully completing the proof in preparation for the challenge problem. At the end of the clip, we see students first prove the law of signs and then apply it to the real-world scenario in the challenge problem on the exit ticket. Of the samples we see, not every student answers correctly, but they all demonstrate movement from where they started at the beginning of the lesson. This clip reflects the key concepts of Essential Practice 2. Challenge students with rigorous content, and Essential Practice 4, maximize student ownership of learning. The teacher carefully chooses material, limits her direct instruction, and focuses her questions to maximize student work time and ensure that students do the majority of the thinking and speaking about the content.